Right, getting into lesson 4, section 4. We're going to be splitting this one up over 2 lessons because this one is something that's just super important because it plays a big part in all future math classes that you'll pretty much probably ever take. It's just writing equations of graphs. And the most common one is writing the equation of a line. So that's what we're getting into. So we're going to split this up over 2 days. So we get good practice on this one. But this is something you would have seen in Algebra 1, and that's just writing the equation in slope-intercept form of a line. So one thing to keep in mind is the reason they call it slope-intercept form is because you have a slope and you have a y-intercept. All right, so we're going to talk about those guys first. This is what slope-intercept form looks like. This should look familiar to you. We call it y equals mx plus b, where m represents the slope, and that's what we've just been working on in our last section, and b represents the y-intercept. So the y-intercept is simply where the line crosses the y-axis. So when you look at a point on the y-axis, right, if I said, what are the coordinates of that point right there? Right, well, we would say the coordinates are 0, 1. For this guy, it would be 0, 2, 0, 3, 0, 4. Right? If I went down here, it would be 0, negative 1, 0, negative 2, 0, negative 3, 0, negative 4. So notice in all those cases, what was the x-coordinate that I just kept repeating? Right? It was 0. So any point on this line has an x-coordinate of 0, and then you would see the y-coordinate would be the y-intercept. So let's keep that in mind as we're going through. But let's just start with some basics here. So for number 1, they want us to write the equation of that line. They're telling us that the slope is negative 4 and the y-intercept is positive 3. So all we have to do in these cases is simply plug in the numbers. If we know the slope and we know the y-intercept, we get to go straight to the answer. So I'm simply going to take my negative 4, plug it in for m. So we're going to do a little substitution right there. And we're going to take our positive 3, sub that in for b, and just like that, we got the equation of our line. If we wanted to graph this, we already know the y-intercept, and we worked on some of this in the last lesson when you were doing section 3, where you were given a point and a slope, and you had to do a graph. Right? So this one starts, we already know the y-intercept is positive 3. Right? We already know it's right here. So that's kind of our first key point. But then where do we go from there? Well, this is where the slope comes in, right? Remember the whole rise over run thing that we talked about in the last section? So we know this one, that's the same thing as having negative 4 over 1. So from this y-intercept, I know to go down 4 over 1. Right? So I'm going to go down 4 and over 1 to get my next point. So then all I would have to do from there is connect the dots, and I have my graph. Let's try one of these guys. As always, welcome to pause video and give one of these a try. You know what I think I'll do for this one? Because negative 8 is going to be off my grid. Let's change that to negative, let's just say negative 2, so that it actually fits on here. But if you want to pause and give that one a try, go for it. So we're going to start by just writing the equation of the line. They gave us the slope of 3. We're going to plug that in for m. They gave us a y-intercept of negative 2. So we're plugging that in for b. So there's the equation of the line in slope-intercept form. What we're going to do from there is graph it. So again, for this one, let me just get rid of the old graph, the old points, so it's not confusing. So for this guy, we know the y-intercept is at negative 2. So that's right here. And where do we go from there? So from there, I'm going to use my rise over run. This one's positive, so we know he's going to go up and right. Remember, we always run to the right when we're graphing these guys. So if it's positive, you go up and right. If it's negative, you go down and right. So on this guy, we're going to go up 3 over 1. And then from there, again, I could just connect the dots, and I would have my graph. All right, let's try these guys. What I want you to notice, and this is kind of what I was trying to make a big deal out of a second ago, is when they give you the point 0, 1, are they giving you the y-intercept with that one? Remember what we talked about over here. Any point on this line, what are the coordinates? Right? It's 0, 1, 0, 2, 0, 3, 0, 4. Anytime you have an x value of 0, the y-coordinate is your y-intercept. So they're still telling you that the y-intercept is 1. They just didn't write it. They just wrote it in this form. They wrote it as an ordered pair instead of saying b equals 1. But that's the same thing, right? So whether they say your b value is 1 or they say it contains the point 0, 1, they're giving you the y-intercept of 1, right? Either way you want to read that. So let's go into the equation of the line. We're going to plug 3/7 in for my slope. And then we got a positive 1 for the y-intercept. Again, we know where to start on this. We know this point is our starting point. 0, 1, the y-intercept is our starting point. And then from there, we're going to do a little rise over run. We would go up 3/7 from our starting point. So I would be going up 3 and then over 7, which is almost off my grid right there. And so I would then just connect those points to draw the equation of that line. And you're welcome to do that. I'm just trying to keep this graph clear so as I create new ones on here, it's not confusing to you. All right, one last one. Again, recognize on this that if my x-coordinate is 0, this has to be my y-intercept, right? So my b value is -6. That's my y-intercept. We're going to write this equation in slope-intercept form, plugging in -2/5 for my slope and -6 is my y-intercept. So again, if we were going to graph it, we know to start at the y-intercept, which would be right here. And then this one's definitely going to be off our grid, but that's okay. So from here, we would go down 2 over 5. So I'm going to go down 2 as best I can here, and then over 5. So that should put me about here. And that would be the equation of our line. So there's our graph. There's the equation in slope-intercept form. So that's one of our main focuses for today. Let's take a look at these guys. So we're at the equation in point-slope form. So now we have a different form. Why do we need a different form? Well, if you'll notice on this one, we know the slope, but we don't know the y-intercept, right? My x is not 0, so this can't be the y-intercept. This has to be just any other point on the line. So if they give me a point and a slope, then naturally we want to plug into point-slope form. Point-slope form looks like this. We say it's y minus the y-coordinate. So we use a little y sub 1 to represent the y-coordinate. That's this guy. That's my y-coordinate. Equals my slope times x minus the x-coordinate. All right, so a little x sub 1 represents the x-coordinate. That's this guy. So notice on this one, they are giving us m. They are giving us the x-coordinate, and they're giving us a y-coordinate. Right? So all we're going to do is plug in those three numbers into this form. And guys, don't forget, these are named for a reason. It's called point-slope form because you're given a point and a slope. Right? And so we're plugging into point-slope form. So let's do a little substitution here. So we're going to say y minus, and we're going to replace y sub 1 with the y-coordinate, which is 2. We're going to replace m with our slope, which is 2. And we're going to replace x sub 1 with our x-coordinate, which is 5. All right. So that would be the equation of this line in point-slope form. If we wanted to graph it, this is pretty much what we were doing at the end of the last lesson. They're giving you a starting point of 5, 2, which would be right about there. And then we just use the slope to tell us where to go from there. So think of this as 2 over 1. So I would just simply go up 2 over 1, And then all we need to graph that line is 2 points. So just draw a line through those 2 points, and you have your graph. I do want you to notice that we can easily take an equation that is in point-slope form and convert it to slope-intercept form. All you have to do is distribute this guy. So on the right side, if I distribute the 2, it would look like this. And then I'm just going to add 2 to both sides. So I'm going to put a little +2 here, a little +2 here. And what do we get? So if I simplify it, now it looks like this. Notice what we have here. This is now the equation in slope-intercept form. This is the y equals mx plus b equation. Right? So now you can look at this and say, oh, my slope is 2, my y-intercept is -8. So it's all a matter of what the directions specifically ask you for. If they say write the equation in point-slope form, then you want to leave your answer like this. Had the directions said write the equation in slope-intercept form, then you would take these next couple steps and write your equation like this. Right? So just read the directions carefully for what they're asking you for. All right, let's take a look at this guy. Getting some extra practice here. So again, I have a slope, I have a point, which means I want to plug into point slope. So we're going to replace this little y sub 1 with the y coordinate, which is -4. Watch out for your signs. We do have a double negative here. This is going to end up being y plus 4. We're going to plug -3 in for our slope. And we're going to plug the 2 in for the x coordinate. So I would do a little cleanup right here and call that y plus 4, but that would be the equation of the line in slope-intercept form. I'm sorry, point-slope form. So there's the equation in point-slope form. If you distribute the -3 and then subtract 4 from both sides, then you would have slope-intercept form. But the directions just said point-slope, so I'm going to leave it like this. So if we wanted to graph it, I'm going to plot my point, 2, -4. And then from my starting point, I'm going to use my slope to tell me where to go from there. And this is -3. Think of that as -3 over 1. So from here, I would be going down 3 over 1. So my second point would go right there. And then again, if I just drew a line through those 2 points, I would have my graph. Let's try a couple with fractions. Fractions can be a little tricky for people, so we're going to try a couple with some fractions here. So this one is giving us a slope of -1/2. My point is -2,5. Again, if I have a point and a slope, I want to plug into point slope. So we're going to start out with y minus our y coordinate. So my y coordinate is 5. We're going to plug the -1/2 in for our slope. And we're going to plug in the -2 for our x coordinate. So it looks like this. And whenever you have that double negative, we should always do a little cleanup on that. That should be x plus 2 if we're going to write the answer for this. Again, the directions on this did say point slope form. So that's the answer they were looking for. I'm going to show you the next steps because eventually we're going to do this anyway. I want you to get you a little bit of practice with this. If I distribute the -1/2. So if I distribute it to this guy, I'm going to get -1/2 x. And if I distribute it to him, so here's where you got to do a little math. So if I did -1/2 times 2, what do we get? We get -1. So that's the next step of this. Again, if I wanted to really get this into slope-intercept form, I always need to get y by itself. So I'm going to add 5 over to here. So if I add 5 to this, this would be the answer in slope-intercept form. Again, just a matter of following directions. So that would be slope-intercept. This would be point-slope. This is what the directions asked for on this problem, so we would stop there. If I want a graph, again, you would plot this point of negative 2, 5. And then from this point, because this slope is negative, you would go down 1, right 2. Let's try one more, and this one we'll put on the graph, and we'll leave it on there. Welcome to pause and try this ahead of me. So my y-coordinate's negative 8. My slope is 1/3. My x-coordinate is negative 3. So here we go. And again, directions said point slope. So I would leave the answer like this. That's my point slope. And you don't need two plus signs. You could just write it as y plus 8 and x plus 3. But that would be the answer in point slope form. You start at this point on the graph. You would plot negative 3, 8. This is going to be a little off our grid here. Call that 8 right there. So it would put me right about there. And then from there, I would have to go up 1, right 3. So up 1, right 3 would put me right here. So this line would go just like this. And that would be our graph. All right. Let me go to one last example. And the rest of this, we're going to save for the next lesson. So let's get one more in here. So what if they said write the equation of the line in slope-intercept form, but notice that we're giving something different on this one. Now I'm just given 2 points. So where do we go on these? Couple things. These are maybe the toughest because these kind of come with the most side work. So one thing we need to figure out is my slope. And this is what we worked on earlier on in the chapter. Remember how you find a slope. We do y minus y over x minus x. So I'm going to do my y minus y over x minus x. And if I clean that up, I figured out that my slope is 3 over negative 6, which we're going to simplify to just negative 1/2. Okay, guys, once you've done that, you are right back into what you just did in the last problem. You now have a point, you have a slope, and we're going to plug that into point slope. So on this one, I actually have 2 points. So really you could pick either one, and it won't matter. If I choose to go with this one, eventually when I'm all done, when I get y by itself, no matter which point I pick, I'm going to get the same equation in slope-intercept form. So point-slope form is simply a stepping stone in this problem. So I'm going to start with this point. I'm going to pick this one because those numbers look a little simpler to me than those numbers. So I'm going to pick the ones that look easier to work with. So I'm going to say y minus my y-coordinate equals my slope times x minus the x-coordinate, which was 3. All right. So that's what it looks like in point slope, but that's not what they're asking for. They want slope intercept. So we're using, in this problem, we're using point slope as just a step in the process. So first things first, we need to distribute. It's always a two-step process to move on from here. It's a distribution, and then we have to move this to the other side. So if I distribute, I'm going to get negative 1/2 x plus 3 over 2, and that puts me right here. So here's where it gets a little bit tough, because now I have to add 2 to this guy, right? So how do I add 2 to 3 over 2, right? This now gets into needing common denominators and all that fun stuff. So we can do that, but I wanted to show you something you could take advantage of, because a lot of times this is where people will make the mistake. When they add 2 to this is where they get stuck, right? And they're going to be like, oh man, how do I add 2 to 3 over 2? And you have to go back to common denominators and all that fun stuff. Let me do it that way first, and then I'm going to show you something else that you could do if you want. I'm going to add 2. So how do I do 3 over 2 plus 2? Right, well, I would need common denominators in order to add those together, right? So I'm going to say 3 over 2 plus 4 over 2. right? Because isn't 4 over 2 the same as 2 over 1? But now I wrote it in such a way that they have common denominators. And all this is old pre-algebra stuff, so I'm sure you guys will remember how to do this after you've practiced it a little bit. Add those together, and I would get 7 over 2. So after adding 2 to both sides, here's what we got. So this is what they wanted ultimately. They said slope-intercept form, which is what this is. And that would be our answer. Guys, we typically don't use decimals. So when you have a slope that's a fraction, we keep it as a fraction. When you have a y-intercept that's a fraction, we're going to keep it as a fraction. So we will typically not use decimals on this. So don't start plugging all that into your calculator and getting decimals. Here's what you could have done. Just an option. You don't have to do it this way, but I wanted to give you another possible path here. Let me back up to this line right here. When I had my point slope, which looks like this, so one thing that you could do on this is, instead of distributing the fraction, because you might look at this and say, uh-oh, if I distribute, I'm going to have 3 over 2. I don't want to have to work with that fraction, right? If this was an even number, just distribute, right? Because half of an even number is going to come out to be a whole number. So if it comes out to be a nice clean number, you might just distribute. But if you're still having this fraction issue, even after you distribute, you might want to do this instead. I'm going to take whatever this number is, and I'm going to multiply it to both sides. So I'm going to multiply the left side by 2, and I'm going to multiply the right side by 2. All right, because remember, it's an equation. You can do whatever you want to an equation as long as you do the same thing to both sides. So I'm multiplying both sides by 2. Here's why. What's going to happen on this side? Well, my 2's would cancel, and I'm left with just the negative 1. So on the right side, I would now have this. And on the left side, I have 2y minus 4. But by doing that, look what you've done. You no longer have to work with fractions. So if you want to take that step, you can do it, not have to work with fractions, and let's see it still work out to be the same answer. So on the right side, I'm now distributing negative 1. My next move would be to add 4 to both sides. Puts me right there. And then my final step would be to divide everything by 2. Everything. So I'm dividing both sides by 2. You have to divide everything by 2 when you do that. So it looks like this. Notice it's the same answer we got right here. Guys, one thing to understand is, if there's not a number right here in front of x, what do we know is there? We know there's always a 1 there, right? So it's not just like 0x, it's 1x. So recognize that this is still a slope of negative 1 over 2, right? Just like this one was. So it's the same answer, but this is a way of doing it if you don't want to have to deal with the whole common denominator issue. Last one, on your own. Start out with our slope. So I'm going to do my y2 minus y1 over x2 minus x1. So if we clean that up, negative 4 plus 2 is negative 2. 4 minus 5 is negative 1. And we get this nice, simple slope of positive 2. So nice and easy to work with on this one. So when you plug this into point slope form, remember you get to pick either point you want. Doesn't matter which one. If you do it correctly, you'll still come out with the same answer here. So I'm just going to pick, I'll just go with the 4's on this one. So I'm going to say y minus my y coordinate equals my slope times x minus my x coordinate. So there's my answer in point slope form. although I would make this a plus. There's my answer in point-slope form. But if they want it in slope-intercept form like this one does, remember it's a two-step process. You have to distribute first. So on the right side, I'm going to distribute the 2. And then I need to move this guy over. So in this case, I'm going to subtract 4. And get that as my answer in slope-intercept form. And that is it for part 1 of this lesson.